Alright, this is section 9.6 homework, log equations and applications. Problem number one, we have three parts. We want to determine if the given values of x are solutions. Now what we can do is plug in each value one at a time and check to see if the left side is equal to the right side. However, what I'm going to do is just simply solve the equation, find the answer, and then we can identify which one is correct from there. So to solve this, we're going to be employing several of the log properties and techniques that we've seen before. So we have log base 2 of x equals 5 minus log base 2 of x minus 31. Okay. I can't get just log equals log because of this term 5. So what I'm going to do is I'm going to move the logs to one side. We're going to rewrite the logs as one log, and then we're going to write it in exponential form, and then we can solve it. So to do that, first I'm going to add this log expression over here so I can get both logs on the same side. So this will give me log base 2 of x. And this is going to change from minus to plus because I'm adding it over, plus log base 2 of x minus 31, and it's going to be equal to 5. So I just move this expression over, change signs. Alright, so property of log says when we add two logs, same base, we can write the arguments as a multiple. So this is log base 2 of x times x minus 31 is equal to 5. Alright, and then from here we're going to write it in exponential form. So 2, this base raised to the 5th power, is equal to this. So we have x times x minus 31 equals 2 to the 5th. Okay. And then at this point, we can employ algebraic methods to solve. So x times x will give me x squared minus 31x. And then if you do 2 to the 5th power, that's 2 times 2 times 2 times 2 times 2. That should give us 32. I'm going to subtract the 32 and move it over here. Minus 32 equals 0. And what we see here is a quadratic equation. And we can solve the quadratic equation either by quadratic formula or factoring. Let's see if it factors 1 times 32 will give us 32. Factors of 32 that subtract and give us 31, that will be the first pair, 1 times 32. If you subtract 1 and 32, you'll get 31. So this factors. Two sets of parentheses, x squared, split it up, 1 and 32. And so we want these two to add to be a negative 31, so the bigger number needs to be negative. This has to be positive, different signs. Alright, so from here, we set both terms equal to 0, and we get x equals negative 1 as one solution, and we get x equals positive 32 as our other solution. So these will be the two numbers that work. Again, you can plug each of these answers in and see if they work out. In this case, we've already solved it, and we can see that 32 is going to work out. You do want to check these, however, just because I get two solutions doesn't mean that they work. One thing you got to be familiar with is that log has a restriction. The domain for just a regular log, x has to be greater than 0. Okay, so that means it has to be positive. So if I plug 32 in, it's positive, I will get an answer. If I plug 32 in, this argument inside 32 minus 31 will be positive, I can get an answer. However, if I plug in negative 1 right here, it will not work, and so this will not be a solution. This is the only one. I can pull up the calculator. I think I have it open. And if I type in, let's just say log, let me clear this out. I don't know what this is. Log, nope. Where's log? Log, and then I do -1. It is going to tell me error. Okay, not real answer. So anything less than 0 won't work, even if I do 0. Log of 0 doesn't work. Has to be greater than 0. Has to be something positive. Error domain. So doesn't work. Be sure to plug them in and check. So 32 is the only solution. So here, is 32 a solution? We'll say yes. Is 16 a solution? No. Is -1 a solution? So even though we solved it and got -1, it does not work because it violates the domain, which has to be greater than 0. Or at least when you plug it in, the expression needs to be positive, and so it doesn't work out.